Okay. So on 1-3, we're going to start diving into the biomolecules and how they're arranged and how they come together, how they're broken. And two words you got to know right away: monomer and polymer. If you had them in class, you know what these, or you may not remember, but you would be familiar with hearing these. Mono means what? One. Mer means unit. So when you see mono, you know, if two people are fighting, they're going mano a mano, toe to toe. But mono means one. So if you're looking at a molecule and it's a monomer, it's one single standalone unit, very much like this. So this would be an example of a very small single molecule. Now that's easy to draw, that's why I placed that up there. Okay, what does poly mean? Many. So what does mer mean? Unit. So you got many units. Okay? And I can't get away with it. I want you guys to think of a metal chain. Say you're going to pull a tractor or a truck. You need a metal chain, much bigger than a dog chain. The chains are made of, what do you call the little things that make up the chain? Yeah. Links. That's the word. And if you put one link to another, what happens to the length of the chain? It's going to grow. And so look what's happened. A polymer is just a bunch of monomers put together. Okay, easy kind of concept. I don't think anybody in this room was going to have difficulty understanding that. I can remember in college, the professor in Bio 1, and I had her for Bio 2, Dr. Dorothy, she kept mentioning monomers and polymers. And if that were back in the days where I had a cell phone and internet, I would have looked it up because I had no clue what she was talking about. She talked like, oh, I thought, wow, that sounded really sciencey. But I didn't know what a monomer was. I didn't know what a polymer was. Okay? Now, what's the difference? Monomers, single units. They make up polymers. They're linked by covalent bonds. There's two covalent bonds that you have to know in AP. We're not going to go that deep. Two types of covalent bonds here. I don't think we go into it. But they're bonded together. Now remember, this is the second strongest bond. So it can be broken. And our body is able to break it. And it's able to create it. So right now, if you had breakfast, your body is taking the polymers in your food and it's breaking it down. And the cool thing is when you break this bond, it releases energy. It releases energy. Especially if it's a carbohydrate. Really, if it's a lipid, it really releases it. Just takes longer for a lipid. Okay? Now, there are two ways. And this is all you got to write. When we're done. I want you to be familiar with creating a covalent bond or breaking the covalent bond. If it's what's called dehydration synthesis, think of dehydration. What are you removing? Water. Don't make it hard. If I say synthesize, am I making? If I synthesize something, am I making it? Yes or no? Think about it. Have you guys know the word synthesize? Synthesize means to make, to create, by removing water. And so look what happens. You get two molecules that are separate. When they get close to each other, look what they do. They join up in a chemical reaction. They create a covalent bond. Look what they released. H2O. Release H2O. When our DNA is replicating and we're making more DNA, this is what's happening. It's releasing the water. But now just on the other side of it, hydrolysis. Again, big word. What's hydro mean? Water. Anybody know what lysis means? It's not license. Say it again. to break, split using water, break using water. Don't make it difficult. I'm teaching you the way I wish it would have been taught to me. Okay, and then you look, there's the picture. Look what they're doing. Adding water and breaking it. So right now, my banana this morning is being disassembled molecule by molecule, and when you do it, it's releasing energy. If you don't believe me, put your hand to your neck. Be swarm. You've got lots of things going on. Okay, uses H2O to break a molecule. Dehydration synthesis removes water to build a molecule. Any questions? Never is.